example you can find on Avenue to Learn. Okay, I want you to download this image from Avenue to Learn. Check. Okay, from Avenue to Learn. This problem is very similar to the last question in your homework. Okay, very similar. Only they use standard SI unit, whereas in your homework, it's in imperial. Okay. So we are not just going to solve for what the actual load for the moment. Okay. We are also going to calculate the stress, okay, for the structure. Okay. So 4 forces are applied to a W200 41.7 row beam as shown. We are going to determine the normal stresses point A and the normal stresses at point B. Okay. So on Avenue to Learn, you will have this image together with the information regarding the cross section of our structure. Okay. So the first thing that we're going to do, we have to resolve what is our axial force, resolve what are our bending moment. Okay. So by looking at this, we understand that we are going to calculate stresses in the Z direction. Pardon me, okay. We are going to calculate stresses, normal stresses in the Z direction, which is equal to PZ or plus minus mx over Ixx multiplied by y plus minus my over Iyy multiplied by x. Okay. Over here. Okay. So once you have this, you have to define your transfer. So what we don't know. First of all, we don't know what is our PZ. We don't know what is our MX. We also don't know what is our MY. Okay. Later on, from the table, we can get what values are our MX, what values are Iyy, and what values are our area. Okay. So those values, okay, regarding the geometry properties of the structure can be acquired from this table. That's not difficult yet. Okay. So let's do the interesting part first. We want to count. We need to know what is our PZ, MX, and MY. Okay. I'm going to copy this image across. And remember what I told you. 3D world in a 2D solving. Okay. So we have to draw our transformation. I'll give you 1 minute relative to the cross section, and you'll sketch the transformation in 3D. Okay. So sketch a transformation on 3D, which is your X, and which is your Y, and which is your Z. Now it's important to follow the transformation over there. Why? Because later on, why that is important? Because if you were to look onto this table over here, let me copy this diagram. On this diagram over here, it happened to be X and Y are in the same what? Same orientation as the question. Be clear. So it's important for you. Or if not, you mix up your Ixx and your Iyy. So now in 3D, I'd like you to sketch where is your X, where is your Y, and where is your Z. Are you confident? Good. Only one confident, bloody hell. Come on, I need more than that, okay? So now we know, right? This is your X. We know that this is your Y. And using your right-hand rule, we know that this is your what? It's your Z. We clear? Focus on right-hand rule. Okay. So from here, we are now going to focus. We are with the diagram. We are going to look at the XZ plane. Okay. So we are drawing our transformation now. So this is our X, and this is our Z. And then if we use right-hand rule, this is your rotation about Y. Okay, so now we are focused on the XZ plane. So when we look at the XZ plane, right, what we see is this. We see the structure looking like this. And then we have some hidden details, which is the web. Then from here, you can draw the forces. Okay, so you have a force down here going in at 25. And then you have an axial load coming down. Or we don't know whether it's axial load yet. Okay. And then we have a force 8 times 10 to the power 3. And you have to put times 2 because you have the front and the back. Okay. And then after that, as important, you sketch your element of interest. This is your element A. And then over here is your element B. And now we have to sketch our centroid. Okay, so our centroid is directly over here. So this is our centroid. Just a sketch. Okay. So from here, you can immediately define what? What is your axial load? Yes or no? Right? This happened to have a very good view. No doubt, if you look at the structure, the 100 kilonewton is not exactly at the center by behind, but if you look at the 2D view, right? You realize that the 100 kilonewton is exactly acting on the where? On the centroid. Okay, so now you can immediately write down, right, that PZ will be equal to 100 times 10 to the power 3 Newton. And we are going to use this formula where PZ is equal, or stress, normal stress in Z direction is PZ over A, right? And you know that it is going to go through what? Compression. So for element A, is it element A? Yeah, element small a and element small b is going to be at what? It's going to be negative compression. Okay. So the next thing that we are going to look at is we are going to focus on the force 8 times 10 to the power 3 times 2. Okay. Now this force is perpendicular to the centroid. Okay. This force, the 8 times 10 to the power 3, right, is perpendicular to the what? To the centroid. When that's the case, the distance, the moment you're going to take is the distance to the what? To the element, and this distance is 0.6. Right? As you can see from the diagram, 500 millimeters. plus 100 millimeters is equal to 0.6. And at this notation, you can see at this force, right, it's going to generate a rotating moment or a moment, and the moment is going to be in this direction. Okay, when that's the case, your moment in y over here is compression, over here is what? Tensile. Right? If you look at the 8 times 10 to the power 3, if you put your fixed point where the elements are, right, the 8 times 10 to the power 3 twice, front and back, is going to generate a anti-clockwise rotating moment. Okay, when that's the case, the head end is in compression, the tail end is in tensile. So over here, you just do the calculation now. You declare that going in the anti-clockwise direction is positive. Then you're going to calculate moment in the y direction, right? Because this is in the y direction. Yep, we are very sure it's in y direction. So it's equal to what? It's equal to force times 10 to the power 3 multiplied by twice front and back perpendicular distance is equal to 0.6. So this will be equal to 8 power 3 times 2 times 0.6 is equal to 9,600 Newton meter. And then when we apply the formula where we have stress in the z direction, which is equal to my over Iyy multiplied by z, right? We are aware that element A is in compression, negative, right? And element B is in what? Tensile. That's due to the moment. Anything else to analyze? And the answer is no, nothing else to analyze. Okay, now listen. Able to break down what is your px, what is your my, that is straightforward. It's important that you are able to define whether it is in positive or negative direction. That is as critical or more critical than anything else. We clear? Okay, so nothing else to do. Next, we are going to look at the different plane. Okay, I'm going to copy the image. I don't give you guys headache. Okay, so now we are going to look at a different plane now. Okay, so the plane that we are going to look at is going to be our YZ plane. Okay, next we are going to focus on our YZ plane. So now this is our Z, and over here this is our Y. So that is our YZ plane. So when we look at our YZ plane using right hand rule, this is our rotation about X. Okay, so next we are again going to sketch the entire structure. Okay, so the structure now will look like this. We have two lines coming down. Then we are going to include our forces. We know that over here you have 100 times 10 to the power 3 Newton. And then somewhere around here, you have 25 times 10 to the power 3 Newton. And then you will have your element A. And then you will have your element B. Okay. Then again, you sketch down your centroid of interest relative to the elements. Now you have two other forces that you don't need to consider at this view. Is the ones in cross, and they are at 8 kilonewton each. Remember what I told you, you don't need to analyze the dot and cross. You just analyze the okay. And then from here, it is not very obvious